Okay, so today we're going to be talking about similar triangles. And so the thing is that if you've got a similar figure, okay, like we talked about yesterday, if you've got a four-sided figure or five-sided figure, all the corresponding angles have to be congruent. And also the sides have to be in a proportional relationship to each other, where there's a common factor or ratio that relates each of the sides. So in this one, the factor is going to be multiplied by 10. Okay. And so sometimes the times by a half. And so today we're going to say, like, if we have a four-sided figure, you've got to show that all the corresponding angles are congruent and the corresponding sides are in a relationship, like in a fraction relationship ratio. But with triangles, because remember we talked about the bigger the angle, the bigger the side across from it in a triangle. That's not true in other shapes, but in a triangle, because there's only three angles and three sides, the angles and the side lengths are directly related to each other. And so um, we've got some shortcuts for triangles specifically. Okay. One of them is angle, angle. One of them is side, side, side. And one is side, angle, side. These are the similarity shortcuts that we can use if we have a triangle. Okay, and we want to say, hey, are these triangles similar to each other? And so over here, again, if two angles are going to be congruent, well, the third angle is going to also be congruent. So basically, if two out of three angles are congruent, we know that the third angle will be congruent. And since the measure of the angles impacts the length of the sides, then we know the two triangles that we're talking about will be proportional to each other. Okay. The third angles theorem tells us that if two out of three angles match, the third one will match as well. The second one is side, side, side similarity. So if we can write down that three sides, all of them are related numerically in the same ratio with each other, the angles must be congruent. And so therefore the triangles will be similar to each other. So think about this. If we did like 3/2, that's going to be this side here. And we did 6/4. And we got to do all three. If we do 7.5/5 and we divide them all, we're going to get 1.5 or 3/2. So absolutely, these will be similar to each other. And then also side angle side. If the angle is congruent between two triangles and the sides next to them are also in a relationship, we could have 3/2. We could have 7.5/5. And the angle in between them, both of those will be reduced to 1.5. So therefore, yes, those two triangles will be similar by side angle side. And there's lots of properties like a triangle is similar to itself. There's a transitive and symmetric property as well. So just heads up. Now we're going to just practice showing, hey, are these two triangles similar? If so, why? And then also, could we write an equation to help kind of find some missing parts of maybe one of the triangles? So given that angle B and D are congruent, they're both right angles, well, we know that these triangles are going to be similar. Well, yeah, this angle here is congruent to that Y, vertical angles. So yes, the two triangles will be similar to each other by angle, angle similarity. To name them, remember, we've got to have the same respective order. So if you do A, B, C, that kind of starts at this angle without a measurement. So it goes to the right angle, and then over here, we could go EDC, would emulate that value. So EDC. There's other ways you could do it, but you have to be correspondingly truthful as you name that. These two, we can write ratios. We don't know any angles, but we do know we got some isosceles triangles, but that doesn't mean that they're similar. So write the ratio of the corresponding sides and see if you get the same fraction. If you reduce all of them, pardon me, you get 3/2 or 1.5. So yes, why? Side, 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 similarity. So triangle, I don't know, we could do FHG. If we did that, we would have to do IJK. I'll do one way to talk about it. The last one on this diagram is talking about the two triangles. Now I spy a triangle and a trapezoid. No, that's not what we're talking about. The triangle is going to be that small triangle at the top. This one corresponds with this one here. And the big one is the overall triangle here, okay? And so the length of the little triangle is 10 and 8. The length of the big one is going to be, over on the side here, is 10 plus x. A lot of kids want to put 10x. That's times. We don't do times to add up the whole length of one side. And then the bottom is 12. So what do we know? Well, the truth is that we know a corresponding angle. So this angle at the top is a member of both of these. So that angle is a reflexive angle. And it also says that these two bases are parallel. So therefore, these two angles here are congruent because of corresponding angles. So it is angle similarity. Okay, and so angle similar. We know one side that corresponds, but that's not enough. So it's either all three sides, two angles, or two sides and an angle between them. So just heads up, it's angle in this case. So the two triangles that will be similar would be like PLM. Okay, so if you follow this around, you could do PLM, and you could do the bigger one, and you do the same thing. You do CLN. That's one way to do it. You just have to make sure that they agree, like you're going the same way around both triangles. Okay, so let's practice. If these two sides are parallel, will the two triangles be similar? Well, why is A and E congruent to each other? Alternate interior angles theorem. Why would these two angles be congruent to each other? Why? Vertical angles. Why would be the triangles congruent, similar to each other? Angle similarity. And so, yeah, so you could write ratios of corresponding sides and solve for missing parts if you knew some more stuff about this. The next one says, are these two triangles similar to each other? So we're talking about this one down here as compared to the one that's on the right. Well, we'd have to write the ratio of their corresponding sides. And so I kind of need to erase this because I actually wrote that with different dimensions. So of this small triangle, the smallest side right here is going to be 6. Of the bigger triangle, the small side is 8. So we could write the ratio of the smaller sides of each of these triangles as 6 to 8. I'm actually not lying. It is 6/8, which is 3/4. That is right. And then the middle sides would be, in this small triangle, would be 9. And of the other triangle, the middle size length would be 12. So it'd be 9/12. And that does reduce to 3/4. And then on the bigger lengths, okay, the longest sides of each of these would be 12 on the small one and then 16 on the big one. Okay, so you do 12/16, and that reduces to 3/4. So would the two triangles be similar? Yes. Why? Side, similar. And what is a scale factor? If you go from PQR to that, you would have to do a ratio of the corresponding sides. So you could do, say, 8/6, which would be 4/3. Okay, so to get from the smaller to the big, you times all the sides by 4/3, which would make it bigger. The next one, we are talking about verify that those two triangles are similar. We have, again, a reflexive side at the top. We've got two triangles, the small one, which is 2 and 3. We have the bigger one, whose left side is going to be 2 and 4 added together, which is 6. And the one on the right, which would be 6 and 3 added together, which is 9. So we have a reflexive angle in the middle, and we have two sides that we're going to check for proportionality. So if we do the left side, we could do 2/6. If we do the right side, we'd go 3/9. Either way, they're reduced to 1/3. So angle J is a reflexive angle. So by side angle side similarity, okay, these two triangles will be similar to each other. Notice we do side angle side. The angle in the middle is the reflexive angle that is the same shape and size in both shapes. So you could do triangle KLG, pardon me, KJL is similar to MJN. Okay, so the bottom two, we're checking to say, are they similar? And if so, why? Oh, this goes with this one up here. So you could write triangle KJL is similar to triangle MJ. Okay, down below here, well, we know this angle is similar. Okay, congruent to that. We also know we've got parallel sides, so we definitely have some alternate interior angles. So yes, by angle similarity, those two triangles will be congruent or similar, sorry. So triangle, we could do KJL is similar to NML. Okay, why by angle similarity. And it's not angle side, it's angle similarity. And then marking these two angles that are going to be congruent to each other, that's going to help us as we write a proportion. So you have to write a proportion of corresponding sides. So obviously 16 goes with 4. We know that. And then we also would have x plus 18 going with x minus 3. Okay, they kind of alternate like that. Okay, they're the ones that are closest to the angle, the common angle that we know. And if we cross multiply, we get 16, x minus 3 equals 4, and x plus 18, distributing 16x minus 48 equals 4x plus 72. Let's get everybody to one side, minus 4x from both sides. You're going to get 12x. Add 48 to both sides. So x is equal to 10. That means that JL is going to be equal to 28 units. And then in the smaller one, we can draw it into two triangles. And this side is 9, this side is 18. You have a common angle here. You also have corresponding angles here, okay, because those two sides are parallel. So it's angle similarity. S does not similarity. You do that thing. There you go. And then triangle, you do GEH must be similar to DEF. Okay, and then if that's 9, that's 18. And then if this right here is x plus 5, then this entire side, which is kind of tricky, is you got to combine like terms. You're going to do x plus 5 plus 9 and be x plus 14. So writing a ratio, you could do 9 over 18 equals x plus 5 or x plus 14. You get 9x plus 9 times 14 is 90 plus 36. 90 plus 3, I'm too tired. I'm just going to multiply my calculator. 9 times 14 is 126 equals 18x plus 90. Let's get all the x's to one side. You get 9x. Get the numbers to the other side. Get 36. X equals 4. That means that ED is going to be 4 plus 5 plus 9. That would be 18 units. All right. Well, thank you so much. I hope you have a great day.